All right, so we were looking at the basic object-oriented programming as supported in C#. Okay, so three main things: encapsulation, creating the class, public-private declarations, right? Inheritance, deriving one class from another, virtual abstract override keywords, right? And then polymorphism. And we discussed that this further goes into overloading and overriding categories, right? Overloading is within the same class. So if we have more than one method with the same name, but with different parameters, then that's called overloading. And if we have a base and a derived class, and we inherit some function, we wanted to change the code for it, that's called overriding, right? So then we discussed that overloading, for example, can be done at the constructor level. We often provide two constructors, right? We can do it at the method level. So we can write more than one function. For example, if there was a compute AVG with 3 parameters, we can have a compute AVG with 4 parameters, right? So as long as either the number or the type of parameters is different, we can overload things as many times as we feel like it, right? The third category of overloading was operator overloading, right? So the operator overloading further goes into the arithmetic operators. So for example, we can create a class and overload the plus, minus, less than, greater than, equal, equal to, not equal to, and so on, right? For the other category of the operator overloading was where we use these square brackets, and these are called indexers. So obviously, operator overloading only makes sense if arrays are involved. Okay. Sorry, not operator overloading. Indexers make sense when arrays or collections are involved. And the regular operator overloading makes sense if we wanted to add a new data type to the language, such as a complex data type or the currency data type, right? Okay, so anyway, I'll introduce arrays and collections in a few minutes, and then we'll further look into this. Last time we looked into the examples of operator overloading for the complex class, for the currency class, right? Anyway, to finish the topic, overriding, as you guys saw, basically involves keywords such as is, as, and reflection. Okay, and of course for overriding we have the abstract, virtual, and override keywords. So hopefully everybody understands when those are used. Okay, so is as reflection is used when a base class reference is used to point to a derived class object, right? So this is the time we need to check what's the type of the actual object we are pointing to, and we need to create another reference of the same type as the object we are pointing to before we can access any of the fields or any of the methods inside that, right? So very briefly, to refresh your memory, let's say we had a student class, okay, with let's say 5 fields. We had a grad student class where we inherited from student. And let's say we added the thesis as the extra field, so 5 fields over here. So thesis is the additional field. Okay. Now, if somebody gave us, for example, student type reference, so somebody created a code like this, student S1. However, they allocated the derived class object, so new grad student. Okay, so if through S1 they wanted to set the thesis, as we discussed, this will work or this will generate a compiler error? Compiler error, because the way compiler works is it will check S1, S1 is of type student. It will go to the student and see is there a thesis. If there's no thesis, this will give you a compiler error, right? Okay, so what was the technique? We can either use the is operator, as operator, or reflection. So the most popular of all three is the as operator because it's the most efficient. So you will do something like this. You will say grad student, let's say GS equal to S1 as grad student. Okay, so basically as we discussed, this will go start from the S1. Okay. So if this is the memory of the computer, so somewhere in the stack area, you will see there's the S1. It will point to somewhere there will be thesis, and somewhere there will be the vtable pointer, okay, which will go to the code area. There will be a lot of pointers over here. One of them will be the type info pointer, okay, which will further goes to the type info, and in the type info there will be something class equal to, let's say, grad student, or name equal to grad student, right? So anyway, in the type info section, there will be, so this is our type info section in the code area in the memory of the computer. For every class there will be one type info, right? So what does this do? This is a runtime operation. It starts from S1, goes to the actual object. So in this case it was a grad student. Then it will go to the vtable. Then it will go to the type info and find out what is the name of the class. If it indeed is a grad student, it will create a reference of type grad student and returns in the, after it does the check, so returns a reference of type grad student if successful, correct? And what happens if it is not successful? What if it is pointing to a student, not a grad student?
Then it will return null.
Then it will return null, right? So in this example, it will return a reference to the grad student. And we can make sure GS points to the same reference. So in this example, the GS will be pointing over here, and GS already is of type grad student. However, you should not blindly assume that it will succeed. You will always write if GS not equal to null, then GS dot thesis equal to whatever you wanted to set to, right? Okay, will the compiler be okay with this statement? What type is GS? And does it have a thesis? Yes. So now through GS, somebody will be able to modify this thesis, right? Okay, so anyway, so that was the polymorphism side, the overriding side of polymorphism. And once again, this is the complication. This is the most complicated aspect of polymorphism when we use a base class reference to point to a derived class object. And we can either use the as operator or the is operator or reflection. So we already went over it. Okay, so now to finish this topic, we need to finish this part over here. We already looked at overloading, operator overloading last time, so let me explain the idea of indexers. But before we define before we go over the idea of indexers, we need to look at the arrays and collections, because only time we use indexer is when we have large data, meaning either an array is involved or a collection is involved. So what's the difference between array and a collection? Okay, so see, if we have to declare a lot of variables, int A, B, C, okay, E. So for example, if you wanted to declare 7 variables, you can either declare them like this, or you can declare them one line at a time, and so on, right? What if you wanted to declare 500 variables? Obviously, writing 500 lines or creating 500 unique names is not a good idea. So this is where we use arrays, right? And before we go to arrays, let me clarify one thing. In Java as well as C#, there's a concept of types. Okay? Types as in data types. Okay? Meaning, what is the data type of a variable that we declare? For example, if I declare int A, what is the data type of A? Int, right? If I say string C, what's the data type of C? String, right? So we have a concept, rather than every time calling it a data type, sometimes people just say types, okay? So types go in 2 categories. They go into what we call value types and reference types. Okay, what's the difference between value type and a reference type? Value type is always created if we need the memory for it on the stack. So that's one difference. Reference type is created on the heap. Okay, so what are the examples of a value type? Okay, the example is, for example, the basic or the primitive data types. Okay, what are the basic or primitive data